Good day and welcome back to my channel. In the next few videos, we'll be looking at probability from a grade 10 level right up to and including a grade 12 level. The probability of an event occurring will always lie between 0 and 1, where 0 is an absolutely impossible event and 1 is a certain event. Let's move on to some probability notation. P of A is simply the probability of event A occurring. P prime of A is simply the probability of event A not occurring. P of A or B, also written as P of A union B, is the probability of event A or B occurring. And P of A and B, which is the same thing as P of A intersection B, is the probability of A and B occurring. Now let's move on to some definitions. Mutually exclusive events are events that cannot occur in the same trial. Example, when we're tossing a die, it's impossible to obtain a 2 or 6 in the same trial. We can only obtain 1 out of the 6 possibilities. For mutually exclusive events, the probability of A and B occurring is 0. As we said, because it's impossible to obtain both a 2 and a 6 in the same trial, for example. Let's move on to the addition rule. The addition rule helps us find the probability of A or B, and it states that the probability of A or B is equals to the probability of A plus the probability of B minus the probability of A and B. Now we know that mutually exclusive events, the probability of A and B is 0. So for mutually exclusive events, the addition rule simplifies to the probability of A or B is equals to simply the sum of the probability of A and the probability of B. Now let's look at an example. This example deals with a pack of cards. Now before we look at the example, let's quickly discuss a pack of cards. A pack of cards is made up of 4 suits, each with 13 cards each, if we don't include the jokers. Now let's look at the example. The example says, a card is selected at random from a pack of playing cards. What is the probability of selecting a jack? Now, there's 4 jacks in the entire set of cards or entire deck of cards, and there's a total of 52 cards. So the probability of selecting a jack is the number of jacks divided by the total number of possibilities. So the answer is simply 4 over 52. The next question is, what is the probability of selecting a heart? Now, there's 13 of each suit, so there's 13 hearts, and a total of 52 cards. So the probability is simply 13 over 52. Now, let's look at the next example, or the next part of this example. The next question says, what is the probability of selecting a jack or a heart? Now, in order to determine the probability of selecting A or B, it's best to use the addition rule. So what is the addition rule again? The probability of A or B, and in this case, jack or heart, is equals to the probability of a jack plus the probability of a heart minus the probability of a jack and a heart. Right, so we're simply looking for the probability of a jack or a heart, so we have to find everything on the right-hand side of this equation. And as we've done previously, the probability of selecting a jack is simply 4 over 52. The probability of selecting a heart in the second part of the question is 13 over 52. And now for the final part, the probability of selecting a jack and a heart. Now, in a deck of cards, there happen to be one card which is a jack of hearts. So there's simply one card out of the entire 52 that happens to be a jack and a heart. Now, this is not a mutually exclusive event because it's possible to select both A and B. If it was a mutually exclusive event, the probability of a jack and a heart would be 0. Now, to find the probability of a jack or a heart, we simply have to add the above terms, and we get 4 over 13, which is the same thing as 0.31. So the probability of selecting a jack or a heart is 0.31. Let's look at the next example. The next example reads, if a fair dice is rolled, what is the probability of getting a multiple of 3? Now, the first thing is to identify that multiples of 3 in a dice is obviously just 3 and 6. So we're looking to get the probability of a 3 or a 6. It's best to find this using the addition rule again. So the probability of a 3 or 6 is the probability of 3 plus the probability of 6 minus the probability of a 3 and a 6. Now we know that tossing a die is a mutually exclusive event, so the probability of a 3 and a 6 is simply 0. The probability of getting a 3, there's only one 3 out of a total of 6 possibilities. And likewise with obtaining a 6, there's only one 6 and there's a total of 6 possibilities. The probability of getting a 3 and a 6 is simply 0 because tossing a die is a mutually exclusive event. So the probability of A and B occurring in the same trial is 0. So the probability of getting a 3 or a 6 is simply 2 over 6, which is the same thing as 0.33. Before we move on to our next rule, let's look at dependent and independent events. Two events are independent if the outcome of one event does not affect the probability of another event. Now, let me explain this using an example. If you looking at selecting a jack from a pack of playing cards, the probability would simply be 4 over 52, as there are 4 jacks and a total of 52 cards. Now, let's assume we selected one card from the deck and we replaced it back in the deck. Now, in the second row, the probability of selecting a jack would still remain 4 over 52, as there are still 4 jacks in the deck, no matter what card we selected, and there's still a total of 52 cards. That is said to be an independent event, because the outcome of the first draw did not affect the probability of the second draw. Now, let's look at an alternative scenario where we're selecting a card and we do not replace it in the deck. Let's still assume we're looking at selecting a jack and the probability in the first draw is 4 over 52. Now, let's assume after the first draw we do not replace the card in the deck. Now there's a different total of number of cards. There's no more 52 cards in the deck. There's now 51 cards in the deck. So the probability now in the second row of selecting a jack would be different, no matter if we selected a jack or not in the first row. This is an example of a dependent event, since the outcome of the first event it affected the probability of the second event. So, in most cases, events that take place with replacement are said to be independent, like with the pack of playing cards example. Now, let's look at the product rule. The product rule is only applicable for independent events. It's very important to note that. And the product rule states that the probability of A and B is equal to the probability of A multiplied by the probability of B. Now let's look at an example. The example reads, given the probability of A is 0.45, the probability of B is 0.3, and the probability of A or B is 0.615. Now this example doesn't give us any specific scenario, it just gives us some probability values. The first question is, are events A and B mutually exclusive? Now let's go back to what mutually exclusive means. Well, mutually exclusive was, the main thing we took from there was that the probability of A and B is 0. This is because two events cannot occur in the same trial. We looked at tossing a die and obtaining both a 2 and a 6 in the same toss, and that was impossible. Hence, the probability of A and B for mutually exclusive events is equals to 0. So, how are we going to solve this question? There's more than one way to do this, but the way that we will use is that we will simply find out what the probability of A and B is. If it is equals to 0, then the events are mutually exclusive. And if not, then they are not mutually exclusive. So, we can work out the probability of A and B using the addition rule. So again, the addition rule states that the probability of A or B equals to the probability of A plus the probability of B minus the probability of A and B. Now we simply have to input our values that they gave us in the question. The probability of A or B is 0.615, the probability of A 0.45, the probability of B is 0.3, and the probability of A and B is what we are solving for. And by solving the above equation, we simply get that the probability of A and B is equals to 0.135. And since it's not equals to 0, we can say, therefore, A and B are not mutually exclusive. Right, let's look at the second part of this question. The second part of the question reads, are events A and B independent? Now, let's go back to what independent meant. Independent events was events where the outcome of the first event does not affect the probability of the second event. We also knew that for independent events, the product rule holds. So, how will we prove that events A and B are independent? Well, if we prove that the product rule holds, then we are proving that events A and B are independent. So that's what we're going to do. We're first going to work out the left-hand side of the product rule, and then we're going to work out the right-hand side of the product rule. And if they're equal to each other, it means that the product rule holds, and that means that the events are independent. Now, let's look at the left-hand side of the product rule, which was the probability of A and B. And that we worked out in the first part of the question, and it was simply 0.135. Now, let's look at the right-hand side of the product rule. The probability of A multiplied by the probability of B. And that was simply 0.45 multiplied by 0.3. And 0.45 multiplied by 0.3 is simply 0.135. Therefore, the left-hand side and the right-hand side of the product rule are equals to each other, which means that the product rule holds. And if the product rule holds, it means that our events are independent. So let's just write that down. So the probability of A and B is equals to the probability of A multiplied by the probability of B. And this means that therefore events are independent. Now, just a quick note, why did we separate out the product rule and do the left-hand side first and then the right-hand side and then say that they equal to each other? Why did we do that? Well, simply because if we stated from the beginning that the probability of A and B is equal to the probability of A multiplied by the probability of B, that means that we are already stating that the events are independent. And that's incorrect because we do not know that the events are independent. We are working that out. I hope you enjoyed this video. Please give it a thumbs up and subscribe to my channel.